Okay, let's start, guys. So today class, I would like to say you need to be bit more attentive. Okay, because we are going to see uh, small derivation type of concept. Okay, so that you will understand how we can calculate the confidence interval. Okay, so be attentive, guys. Otherwise, it might be a bit difficult for you to follow. Okay, oh, fine. So yesterday, what we have seen, yesterday we have seen uh, the confidence interval part. Okay, so we understood the relationship between confidence interval, confidence level, and level of significance. Okay, a small recap would be, for every confidence interval, you need to have a corresponding confidence level. Okay, for every confidence interval, okay, you need to have a corresponding confidence level. Now, there is something called as level of significance. Okay, whose relation is this way: confidence level plus level of significance will always be equal to 1. Okay, so if you increase confidence interval, level of significance will decrease. If you decrease level of confidence level of significance will increase, because they should make up to 1 always. So for a 95% confidence level, okay, what does it mean for 95% confidence level? Means if you are proposing a confidence interval, some range with 95% confidence, okay, then your alpha will be 1 minus 0.95 by 0.05. Okay, if it is 90, it is 0.1. Okay, fine. So now in today's class, we will try to understand this formula a bit in more detail. Okay, this formula. Fine. So what is this? It is saying the population, if the population variance is known, okay, x bar plus z alpha by 2 into rho, this one. Okay, so let me just see if we can have this formula. Confidence interval formula. Yes, guys, this is the one. Okay, confidence. Yes, this is on confidence interval. Okay, I would say this x bar plus z into rho by n. Same thing, right? X bar plus z into z at alpha by 2, we will see, into rho square root by n. Okay, so if you are getting confused what it is, let me just okay, perfect. Super, guys, let's start. Okay, so this is z will be at alpha by 2. Okay, x bar plus or minus z at alpha by 2 into rho by square root n. Okay, so we will try to understand this formula a bit more, so which is very helpful for you to understand few concepts. Okay, so now let's try to step back. But may I know, like, are we good till this point actually? So from the last few classes, we are trying to understand this formula and then confidence interval, etc. But at least yesterday we have discussed, right? Confidence interval part, confidence level part. So any doubts in that, guys, or are we good till that point? Okay, fine. I hope then we are good. Fine. Let's start, guys. See, now initially, see, as I said, we will see how this formula came into picture. Fine, how this formula came into picture. So wherever you are losing track, you can just stop me over there. Okay, fine. Let's start. See, first of all, what was our concept, guys? Our concept was from a given population. Okay, from a given population, take take multiple samples. Okay, and you will have multiple x1 bar, x2 bar sampling distribution, and you will have a mean of this. The mean of this will be the x bar. Okay, and then what we have said that the sampling distribution will follow a normal distribution. Okay, the sampling distribution will follow a normal distribution. Okay, whose mean will almost be equal to the population mean, and its standard deviation will be square root of rho divided by square root of n. So rho by square root of n. Okay, same thing. See, mu rho square by n, or square root of if you do square root, it will become rho by square root of n. Okay, so this is what we have understood. Now our goal is to, okay, see, listen carefully. Our goal is to capture the population mean. Okay, our goal is to capture the population mean. Okay, but we are saying the sampling distribution mean. Okay, the sampling distribution mean, whatever you are going to get, that is almost equal to population mean. Okay, but since we don't want to go with a single point estimate, we will give you a range which is called as confidence interval. Okay, that part we are good till yesterday. Now here, if this is a distribution, okay, if this is a distribution, okay, if you want to capture this mu, okay, if you want to capture this mu, okay, so what are these values, guys? So you will have some x bar. Okay, so see, if mean is x bar, okay, these are the values, right? So how did you get this graph? This graph is from x1 bar, x2 bar. Okay, some x1 bar, x2 bar, like that. You got some values. Okay, and the goal is somewhere between this x1 bar, x2 bar. Okay, you are able to capture the mu. Agree? This graph, what is this graph? This graph is a sampling distribution graph. Okay, it's a sampling distribution graph. What is a sampling distribution graph? You took multiple samples from this population, and for each of the sample, you have calculated a mean, x1 bar, x2 bar, like that. Okay, and the mean of all these means is x bar, which I'm saying will be equal to mu. Okay, so but to, instead of directly, that means x bar is acting as a point estimate to mu. Okay, but since we don't want to give a point estimate, we are going to give a range, which is called the confidence interval. Okay, that means what I will say, this will be present between, so you are having x1 bar, x2 bar, till like that x10 bar. For example, you took 10 samples. Okay, so somewhere between this x1 bar, x2 bar, okay, these values, you can capture the true population. That means it could be between x3 bar and x5 bar. Okay, somewhere. Okay, you need some x bar. Okay, some x bar you need. Okay, so that it will capture the mu. Okay, are we good, guys? I would like to go step by step here. Okay, because I don't want you to guys lose track. Are we good till this point? Any confusions? Or you did not understand? That's fine. You can let me know. I'll explain again.
Understood, sir.
Okay, perfect. Fine. So now this is a normal distribution. What is this? This is a normal distribution. Why this is a normal distribution? Because from the central limit theorem only, the theory itself says the sampling distribution will follow a normal distribution whose mean is almost equal to population mean and whose standard deviation is rho by square root of n. Okay, that from there we can assume that this is a normal distribution. Okay, and our goal is to capture this mu. Okay, so we are assuming that somewhere between this x1, some x, okay, we need some x bar. Okay, between this, between those values, you can capture this. Okay, but now how to give that exact range? Okay, that range is itself the confidence interval. So if you remember, we also studied something called as standard normal distribution, okay, which is a special case of normal distribution. Okay, so that will come to our help now. Okay, so if we want to convert this normal distribution into a standard normal distribution, okay, what is standard normal distribution? Just to give a recap, where mu equal to 0 and standard deviation equal to 1. Okay, it's a mu equal to 0 and standard deviation equal to 1. Okay, so that means it will also be a normal distribution. Okay, but mean will be 0. Okay, and the standard deviation will be 1. Okay, fine. So now if you see, you have converted these into, if you want to convert these into a normal distribution, so obviously you need to calculate certain values. Okay, so how you can convert these distribution into standard normal distribution with the help of z value. Remember, z equal to x minus mu by rho. Rho here will be rho by square root of n. Okay, z formula, z equal to x minus mu by rho, or rho standard deviation is rho by square root of n. So for each and every value, if you apply this particular formula, okay, all these values will be converted to a corresponding standard normal distribution values. Okay, that will be converted to a standard normal distribution values. Okay, so now here we want to know this particular value. Okay, so here we are having, okay, so over here, so if you see, obviously when you have mu, okay, so it is converted into 0. Okay, so next thing over here, what we need to calculate over here is, when you see, when you say, okay, when you say at a confidence level of 95%, okay, see here, observe, at a confidence level of 95%, okay, means what? Means alpha equal to 1 minus CL confidence level. Okay, that means what? 1 minus, what is 95%? 0.95. Okay, which will be equal to how much? 0.05. Okay, so if you don't want to give any value of 95%, just say alpha. Okay, so now what will be the confidence level, guys? Okay, we'll come to this. Okay, instead of taking a one value 95, 90, we will see those examples, but just as a general way. Okay, so now confidence level will be what? It will be 1 minus alpha. Okay, 1 minus alpha. So if you see whatever we are going to get here, okay, earlier what the range what you are having, okay, the earlier what the range what you are having, so those values will be what? That value will be some x bar values. Okay, some x bar values. Agree? So now the x bar values are converted into some z values, because in the standard normal distribution, this x bar, each x bar will be converted into some z values. Okay, so observe this. Now when you want when you are looking for the normal distribution, you would need the x bar values for the range. But when you convert that into standard normal distribution, okay, I need a range of z values. Okay, I need a range of z values. Z values. That means what? That means what? See, if at all you are looking for, okay, if at all you are looking for a some confidence level, okay, with which you want to predict, sorry, with which you want to suggest a confidence interval, that confidence level will be obviously, okay, 1 minus alpha. Okay, so assuming that this is some range, okay, so that in between this will be, okay, so in between this area will be 1 minus alpha. Okay, the confidence interval wherever you are predicting, okay, from this point to this point, okay, some point I'm saying, okay, to this point, okay, I am predicting, okay, I am predicting with this confidence level, okay, and that confidence will be 1 minus alpha. Okay, it will be more or less will be area. Okay, this -1 and 1 are just the standard deviation case of a standard normal distribution. Okay, so I'm just giving you standard normal distribution. Okay, so that's why I have mentioned 0 will be the mu, and somewhere you will have the standard deviation of 1. Okay, but see, just it's simple. So if at all in the normal distribution, if you have some x3 bar, guys, okay, some x3 bar, and let's say this is x4 and this is x5 bar. Okay, from where you are getting x1, x2, x3 bars, so you took some 10-20 samples, right? So those values only are this. Okay, so if you just focus on the normal distribution, you want this x3 value, x5 value, so that in between that you can capture the true population. Clear? But you are converting this whole distribution into standard normal distribution. So each of this value will be converted into its corresponding z value. Okay, the mu will be obviously 0. Okay, the mu will be obviously 0, and x1 will become its corresponding this z. This is called z score, right? So each of this value will have its corresponding z score in the standard normal distribution. Okay, so now in place of finding the x bar, we would like to have the z values. Okay, there will be some z here. Okay, this will be some z. Okay, and if this is 0, the positive side will be having plus z, and negative side this will be minus z. Okay, clear? Let me stop here. Okay, is this clear? Did you guys follow till here? No? Yes. Mhm. Okay, so that means you will not follow. That's fine. See, guys, I'll repeat again. Don't worry. See, just understand this point. Our goal is to give a range which is called confidence interval. Okay, it will be some interval sort of thing, which can capture the true population. That is our fundamental goal. Initially, you have a sampling distribution x1 bar, x2 bar, like that, which will follow a normal distribution as per the center limit theorem. Simple. Now, which will have the mean will almost equal to the population mean. Okay, let's put this aside. But you want to give a range, okay, between which you can capture this mu. Okay, between which you can capture this mu. And what is the range? If at all you want to focus only on this normal distribution, okay, so obviously what are all these points? Each point will be this x1 bar, x2 bar. Okay, those are those values, right? So which give us normal distribution. Okay, you can use those values, and you need to calculate some x bar, x3 bar, or x5 bar, or some x3, x4 bar. Okay, some bar between which okay, if this is a confidence interval between which you can say we can capture the true population mean. Okay, this is one point. But to make it easy, we convert this normal distribution into standard normal distribution. When you convert this normal distribution to standard normal distribution, what happens? The mu becomes 0, because standard deviation mu and mu equals 0, standard deviation equal to 1 for any standard normal distribution. That's why mu became 0 over here. Now, all the x1 bar, x2 bar, all x bar values will get converted into its corresponding z values. You remember or you forgot this? Because in normal distribution, if you see stand normal distribution, how you are going to convert it into stand normal distribution, guys? X minus this is normal distribution. If you see the z score, stand normal distribution, somewhere I might have written x minus mu by rho, or I will show you from over here. See, x minus mu by rho. I've shown you this example. That means what? To convert a given normal distribution into stand normal distribution, you need to use this formula. Agree? So like that only, what we are doing, we are trying to convert, okay, we are trying to convert this normal distribution into a standard normal distribution. Okay, so that this x3 bar, x2 bar, all x bars will have its corresponding z values. Okay, so now we just want to know that particular z value so that you can calculate the confidence interval and give you, so that between that you can say you can capture the true population. Is this clear?
Yes, sir.
Okay, fine. So now till here we are good. So now obviously when I say we are trying to give some confidence level, okay, that confidence level will be 1 minus alpha. Okay, that means between this, so whatever the range we are saying from this interval to this interval, okay, the area in between this will be 1 minus alpha. Okay, now what will be the remaining? Overall will be 1. Okay, overall will be 1, and only if this part is alpha, what will be this part plus this part? This part plus this part will be alpha, right? Agree, guys? Overall area will always be equal to 1. So only this middle part is 1 minus alpha. That means remaining part is alpha.
Yes, alpha.
Okay.
Yeah, alpha.
So this and this will be alpha. So one side will be, this side will be what? Alpha by 2. This side will be alpha by 2. Agree? So alpha by 2 plus alpha by 2 will become alpha. And if you add 1 minus alpha plus alpha, 1. So overall area is equal to 1. Is it clear? Right? So this will be 1 minus alpha and remaining part will be alpha. So what each side will get alpha by 2, alpha by 2. So that means this particular part, whatever you want to calculate, this will be z at alpha by 2. Okay. And this will also be z alpha by 2. But this is z alpha by 2, but this is minus z alpha by 2. Getting? Okay. So now our point is just if you want to give this area, okay, so if you want to give this area, so you need to calculate these values. Okay, but from this, how did we come to this formula? Okay, how did we come to this formula? Okay, so now you want to now the point is over here. So our probability, okay, so to calculate, so the formula starts here. Okay, so probability, okay, to find z, okay, so probability to find our z value, okay, is in between z alpha by 2, okay, and minus z alpha by 2. Okay, from here you will have, if you try to solve, okay, so but what is our actually our z, like what is our corresponding z score? This is x minus mu by rho. Okay, so this is a probability of z into alpha by 2, okay, less than, our z is this one, x bar minus mu by rho by square root of n, okay, z alpha by 2. Okay, in other words, we are seeing what is the what is the probability, okay, to catch this x minus mu by rho by n, okay, our z score, okay, in between minus z alpha by 2 and plus z alpha by 2. Okay, so and if you just try to solve for this, what happens, guys? So see, simply this will go here, okay, and x bar will also go here, and mu. So our goal is to calculate this mu, right? So if you just solve the formula, you will get x bar equal to this will go and multiply here, and the sign will change. Okay, this will become x bar plus z into alpha by 2 rho by square root of n. Okay, and this will become x bar minus z into alpha by 2 rho by square root of n. Okay, if you just solve this equation and if you just put mu, all these values will be this one. Okay, so this is a formula which we have. So the same formula, x bar plus or minus z into alpha by 2 at rho is alpha by 2. It will be x bar plus or minus z into alpha by 2 rho into square root of n. Okay, so like this, I just want to show you the derivation of this formula. Okay, so how we are actually getting that? We are in this example, what we are trying to do here is we are saying the probability to find the mu. Okay, see, there is actually a fundamental point many people will confuse here. Here we are not trying to find mu. Okay, that is a big blunder mistake if you try to think that we are not trying to find the mu. Okay, because mu is already a actual value. What is mu? Mu is a true population. Okay, we don't need to find that, it is already present. Okay, but what we're trying to say here is our confidence. Okay, how much confident if you're, let's say if you're 95% confident, okay, 95% of the time I'm confident that you can capture the this mu which is already present, which is some very good value. Okay, let's say it is some 1000, a population means 1000. Okay, but I am 95% confident that I can capture this mu 1000 between these values. Okay, this value if you can calculate, okay, if this value you can calculate, right? So what is this value? This is this formula. Okay, this in this formula, what you know, x bar, okay, which is sample mean, and now you know z alpha by 2 also, because what is z alpha by 2? So this is a point on the z table. Okay, we will see how you can calculate that. Okay, so after that you're having rho is what? Population variance. Okay, why? All this is possible only when you know the population variance. Okay, all this is yesterday class I told you, all this is possible when you know the population variance. If you don't know, then there is separate method, we'll come to that. But first of all, in this method you should know population variance. Okay, so population variance is known and square root of n is a sample size. Okay, so that means what? This interval will tell you that in this range what is the probability that I can capture the true population. Okay, it's not about the finding the true population. That should not be your goal, because true population is already there. But I just want to know where it is falling. Is it between 10 to 20 or 50 to 100? And if it is 50 to 100, how much confident I am? That is all. It's our doubts. It's not nothing about the true population. True population is already very solidly sitting over there. Okay, it is already present over there. All these things are calculations from our side, so that we will be confident, okay, between this range I am 99% confident I will capture the true population. Getting, guys? Getting my words? This means that in this range, okay, I am 90%, 95% confident, 90%, 75% confident, so that I will capture the true population. But we are not finding the true population. True population is everything is not being done to calculate or to find out a true population. It is a perfectly already present value. Okay, we are just trying to see which range we can capture that. Okay, which range we are capturing and what is the confidence level we can do that. Getting? Any doubts in my words? Okay, tell me what are those doubts. Okay, fine, then I assume that you guys understood. Okay, so now it's not about the true population. Yes, Karthik, it's not about, we are not about finding the true population. Okay, true population, for the population whatever you are having, that it will have a mu, so that is already there. This whole thing what we are doing is to give a range which is called confidence interval, okay, which we will think that okay, this interval will capture the true population, this interval will not capture the true population, or this will capture with some confidence level, 99%, 90%, 80%. Okay, that is what we are trying to do. Okay, so okay, cool, fine. So now we'll go one step ahead. Okay, so now here what happened is, so I will just do we have shape? We don't have that shape. Okay, see, let me draw this. So now what happened is, so same graph I'm drawing again. Okay, so you are having over here. So now since this is a standard distribution, we are having 0. Okay, so and somewhere the confidence interval here you are having z. Okay, so even if you are getting confused a bit of this derivation, that's fine. Okay, you can take this later, but just try to understand the fundamental point over here is confidence interval is x bar plus or minus z into alpha by 2 rho by square root of n. That's it. Okay, and you know x bar, you know rho, you know square root of n. The only thing over here is this z into alpha by 2. Okay, how we can do that we will see. Now z into alpha by 2 is plus or minus z into alpha by 2. Okay, that means one side you will have plus z into alpha by 2 and other side you will have minus z into alpha by 2. Okay, fine. Now if this is a standard normal distribution, perfect. So now we'll see for 95% confidence interval. Okay, so for a 95% confidence interval, what happens? See, for 95% confidence interval, sorry, confidence level, guys. Okay, 95% means confidence level. Okay, so for 95% confidence level, what happens? So we need to calculate these values. Okay, we need to just calculate these values. So this range will be 1 minus alpha. So why 1 minus alpha? Confidence level itself 1 minus alpha. Okay, see, confidence level itself 1 minus alpha, because confidence level plus alpha will be 1, confidence level will be 1 minus alpha. Okay, so whatever the range we are saying, okay, see, I'm saying the true population mu will be captured, okay, will be captured between this interval. And what is it, with what confidence I'm saying? CL is a confidence, and what is CL? CL is 1 minus alpha. Okay, that means this range, okay, this range will be 1 minus alpha. Okay, fine. And as I said, the remaining part will be alpha by 2. Okay, same thing. Okay, remaining part, this will be alpha by 2, this will also be alpha by 2. Fine. So now when I say now for the 95% confidence level, okay, and what will be the 1 minus alpha? So see, what will be the 1 minus alpha? If you see 95% confidence level, 9 will be, see, 95% will be 0.95. Okay, 0.95. And 1 minus alpha will be what? 1 minus 0.5. 0.95 will be not 0.5, 0.05.
0.0, yes.
Okay, so that means what? 1 minus alpha is 0.05. Okay, 1 minus alpha is 0.05. Okay, now 0.05 is, now it will be 0.05 by 2.
2
will be 0.025. Okay, so now for a confidence level, okay, so for a confidence level of 95%, okay, for a confidence level of 95 percentage, okay, so this alpha will be 0.025. Okay, so this alpha will be 0.025. So that means you need to calculate z. Okay, so and okay, are you good? Alpha will be 0.025. So not alpha by 2, right? Sorry,
alpha by 2.
Yeah, alpha by 2 will be 0.025. So now see guys, so if it is 1 minus alpha is what I'm saying, 1 minus alpha is 95%. Okay, so that means what actually it will be, if you take total as 1000, okay, if you take total as 1000, okay, so 1 minus alpha is 95%. Okay, see 1 minus alpha itself is confidence level. Okay, that is I am saying this confidence level is 95%. Okay, so that means if you take 950 for example, okay, so confidence level itself is 950. Okay, so 1 minus alpha itself is 950. Okay, so this is 950. Okay, so this is 950. So what will be the remaining part? The remaining part will be
50.
so if you remember the area, okay, the area part, fine. So whatever you, if you want to calculate this area, okay, starting from, okay, this area, so till here you will having alpha by 2, right? So what will be the area? Okay, if this is how can I let you know, for example, see guys, this is 950 done. What will be the remaining?
Total is 1000. That area is 950. Remaining is like 1000 minus 950.
Okay, that means how
Yeah.
much?
50.
50, and 50 by 2 will be
25 both sides.
25. So this side will be 25, this side will be 25. Okay,
Yes.
so but if you want to find out the, we want only till this point, okay, alpha z into alpha by 2. Okay, if you want only till this point, okay, till this point, now what is the, now what is the
We
area?
we need to total minus subtract that that part.
Yeah,
This
okay, no, but if you see the area part, you will have, if x is less than 4, okay, x is less than 4 means from 4 you will get the overall area. Okay, so that means till this point how much it will be? So it will be 1 minus see this part, whatever you are having over this part, so this is a point where you will have 950. Okay, this is a point where you will have 950. Okay, and this part is, okay, this part is 0.
0.
0.25, that will be 25. Okay,
Okay.
so which will give you 0.975. Okay, so if you go here and if you just see the z table, okay, mhm. At what value this, okay, so what was our value? Sorry, our value is 0.975. Okay, so because this alpha value is, we got 0.025, and if you add 950, so we got 975. Because this alpha, it is present over here guys, alpha is over here, so this value you need to calculate the area, so that for this calculation of area, what you want, so you need some the value. So how we are getting the value? So overall this is 950. I'm saying the remaining part will be 0.25. Okay, that means this and this part. So if you, sorry, 0.50 by 2, you will get 0.025. Okay, so if you add, so if you want to reach this point, so you should cover this area and also this area. Okay, this area plus this area will be 0.025. Okay, so now if you come over here and see, okay, the area, okay, so what was the area? 0.97 area. So what is the point? Okay, what is the point that is covering 0.975? Okay, to get this point, what does this point will do? This point will cover the area less than and equal to that. Guys, don't lose track. Okay, see, I'm saying in any normal distribution, if I say this is 3, that means what? If I say 3, the area, whatever the value you are seeing, this area will cover what? X, and X is less than or equal to 3. Cumulative probability distribution concept. Forgot.
Like
You
we
see,
need to
if I say 1, if I just say what is the area between 1 and 3, what you will do is you will calculate X for X is less than or equal to 1. That means all this area you will get, and X is less than or equal to 3. All this area you will get. From this, you
and
will
3
subtract
minus
this.
here. Yes.
Remember? So that means what?
Yes.
For any value you give, X is less than some value 100. That means wherever 100 is there, below X is less than or equal to 100, it will calculate the whole area.
From 1 to 100, we need to sum up.
Yeah. Okay, we don't know whether it is 1 or -1 or what is the range. Okay, but from X less than, below that, all the value it will take. Okay, Meghana, did you remember that? Meghana,
Yes, sir.
you remember this concept? Cumulative probability distribution part. If you take any value, it will calculate less than that value. The whole value less than that.
Yes, sir.
Okay, yeah. So similarly here also, I am saying Z into alpha by, I want to know Z into alpha by 2. Okay, but how much area this is covering? This is covering this 950 part and also this small part, 0.25 part. Okay, that means 0.97 part area, or 975 or 0.975 area, this Z alpha by 2 is covering. Getting? So I want to know which point on the Z table is covering this much area. Earlier, what we used to do, if you know these points, you will find out the area. Okay, earlier, if you know these points, if I say 1.1 and 0.01, you will calculate this, where these are meeting, you will calculate that area. But here it is reverse. You already know the area. From where you are getting the area, the level of confidence is your area. So 95% confident. Okay, then from that you will have this area. Okay, so now you already know 0.975 is the area that is covered by this point, which is this Z alpha by 2. But I don't know what is that point. So go and check which particular point is covering 0.975. Okay, so if you see 0.975, yeah. So if you see here, can you see this 0.975?
Yes, Santosh, plus
Okay.
1.9.
9,
Yeah.
and in the top what you have 0.06. Okay, so plus 1.9 and 0.06, it will give you 1.96. Okay, okay, 1.96. So my Z alpha by 2 is 1.96. Clear? That means
Yes.
my formula is converted into simply X bar plus or minus. Okay, what is my formula? X bar plus or minus Z alpha by 2. What is my Z alpha by 2 now? 1.96
Plus 1.96.
into what? Rho by square root n. Rho by square root of n. Getting? Simple. So X bar you already know, sampling mean 1.96 you calculated. Rho is a given population variance or standard deviation. Okay, this whole thing. Okay, rho by square root of n will be the standard deviation of the given population. Done. You calculate this. Okay, put some values. Okay, let's say you, after putting some values, you got this a plus or minus, right? So you got let's say for example X bar is 30. Okay, and plus or minus, if you calculate this value, you got some 3. Okay, so this will become 30 plus 3 will be 33, and 30 minus 3 will be 27. Fine. So some X value will be between this. Okay, now what is this X? This X is our mu. So we can say, now what is the point? We can say that I am, for what particular confidence level you did all this? What is the confidence level we considered?
Here we have considered 95%.
Right. So now our point here is, our statement is, hey, I don't know what is the true population. Observe my words, guys. From whatever the population we have considered and whatever the samples we took, all this thing we have did, our statement finally is, from the population which I took all these samples, that population ka mean I don't know. Okay, because Because if I know that mean, there is no need to do all these things at all. We already know the complete actual true population value or true mean population mean value, because most of the scenario we will not be having that value. So that is the reason why it is leading everything to this. Okay, so now my statement is, hey, there is a population for which I don't know the mean. That's fine, but I took some samples, from that I got the sampling mean. Now I am giving you a range, this range 27 to 33. Okay, so my confidence, now here I can state that my confidence interval is, okay, my confidence interval is, okay, it is 27 to 33. And with how much confidence I'm saying? With a confidence level of 95%. So I am saying, hey, I will be 95% sure that the true population, whatever it is, which I don't know, but I'm 95% sure that will be captured between these values. That is my statement. Getting
Yeah, Santosh.
clear?
Yes.
Okay. That is the point over here. So I'll show you one more example. Okay. For example, you don't want to go for a 90 or let me go for 75%. Okay. So if you want to just go for, okay, I just want to go for 75%. Okay, 75% confidence level. Okay, 70% confidence level. Clear? So now what will be the scenario, guys? What will be the scenario? So now the same graph will come over here. Okay, you have this graph. Fine. So let me draw a little wider graph. Okay, so you are having this graph. What is this graph? This is standard normal distribution graph. So when I'm saying, okay, so you are having some values. Okay, what is this? This will be again Z alpha by 2, and this will be minus Z alpha by 2. Okay, between these are ranges. Okay, I don't know what are these ranges. Okay, I will calculate. Okay, between these ranges, okay, between these ranges, my true population will be captured. Okay, this is the confidence interval. Okay, now what happens over here? So I'm saying confident. I want to be confidence level. Sorry, 75% confident only. Okay, so when I say confidence level, what is confidence level? It is 1 minus alpha. Clear? Alpha is significance, level of significance. So my confidence level is 75. Okay, so 75 means how much it will be? It will be, okay, it means in between this you are having 0.75. That means this particular range I am saying with just 75% confidence. Just how to I said this confidence with 95. Now this confidence interval, what are these ranges? I don't know. I need to calculate. Okay, so I am saying 0.975. Okay, 0.975. I am saying with sorry, this is confidence level. Okay, 0.75 is a confidence level which I am saying this confidence interval. So now to calculate this, I need this value. So from overall 1000, okay, so if you calculate 750, anything you can take 100 or anything. So how much will be left, guys? 250.
250
And
by
this
2.
side, so this side will be alpha by 2, this will be alpha by 2. So each side will get 150.
125,
So sorry, 125. That means in other words 0.125. Okay, so this side this will be 0.125. Okay, and this side the area will be 0.125. So now my goal is this side I don't want, because I am stopping over here. Okay, so this particular point alpha Z by 2, okay, this particular point is capturing how much area? This area plus this area. Agree? This area plus this area, it is capturing. So if I know what is the value in the Z table which can capture this much of area, what is this much area? 0.7 plus 0.125, how much it is, guys?
0.875, I
Okay,
guess.
so a combined, okay, from here to here, okay, this area is 0.875. Okay, so I want to know what is that value. This is the area I already got. Okay, so because from confidence level, this we will get the area. Okay, so we are saying what is that value on the Z table which is covering 0.875% of area. If you know that value, obviously that is a Z alpha by 2. Getting? So 0.875, 874, 6, 3. Yeah, guys, 0.8749. This you can consider it as 875. Okay, 0.8749. Okay, what is this? 1.1 plus 0.05. Okay, so 1.1 plus 0.05. Did you see? 1.1, 0.0.
Yes.
Okay, so how much it will be? 1.15. So alpha by 2, this value became 1.15. Now this became minus 1.15. Okay. Clear? So this is a point which is capturing this much area. Okay. Now our goal is to find out alpha by 2 because in our formula we want that. That's it. Nothing more than that. In our formula I want Z alpha by 2. Now I got Z alpha by 2. Okay. Now if you see Z alpha by 2, okay, if you see Z alpha by 2, now my formula becomes X bar, okay, plus or minus 1.15 into rho by square root of n. Okay. Rho by square root of n. Okay. Clear? This is a confidence interval. I am proposing at 75% confidence level. Getting?
Yeah, Santosh.
Earlier, how much we got? 1.96. Okay, into square root of n at 95% confident. Okay, so now we are having at 1.15 at 75% confidence level. Getting the concept how you can calculate the confidence Z value based upon the given confidence level. So first you need to decide how much confident I want. From that you will have the alpha. From that you can calculate this. Okay, so from that you will get the confidence interval. Okay.
Yeah, Santosh.
Yes, sir.
Clear, right? So because this should be because see, honestly I'm saying in most of the scenarios, okay, so they will directly go to this formula. Okay, so in any video you see, most of the courses also, they will directly go to this formula. They will say this is a confidence interval, X bar plus Z into alpha by 2 rho by n. Okay, that's it. From here you can calculate. But how this is possible from normal distribution to standard normal distribution, from there you just want to know the Z values. Okay, so by using the Z score, okay, this derivation I have explained just to know you, just to give you a background. Okay, because sometimes if you are getting confused with this formula, you can just go back. Hey, how did I get that? It is simply from central limit theorem and I'm getting normal distribution, because that is the philosophy of central limit theorem. Any sampling distribution will follow a normal distribution. That you should not have any doubts. Okay, any sample distribution will have a normal distribution. Okay, will have a normal distribution. Okay, from there we are using the advantage of our concept which we studied called as standard normal distribution. Okay, we are converting standard normal distribution, and from there we are deriving this formula. Okay, so that is one part. Okay, so after that, don't worry about the derivation. You should worry about the formula. So now we have this formula X plus Z into rho by n. Okay, so Z at alpha by 2 into rho by n. So at each individual confidence level, it will be changing. Okay, and also if you observe this formula, X bar will be constant, rho will be constant, n will be constant. The only thing that is going to change is alpha by 2, Z at alpha by 2. Okay, if this value change, this whole thing changes. Agree? And now when this will change when this alpha changes. And when this will alpha will change when this confidence level changes. That means based upon your requirement, I want to be 90% confident. Correspondingly, you will have this alpha level. Based upon that, you will have Z level. Okay, so that's why as you change the confidence level, indirectly the confidence interval will also change. Okay, that is a relationship between confidence level, confidence interval, and alpha level of significance. Clear?
Yes, sir.
Okay. Let me just see. 4, 12. Yes. 12. Okay, having certain values, fine. I would say those are the concepts. And post that we have a very good example over here. But let me see. Meghna, do you have time, or are you going to college, or can we see an example? It's based upon you.
Yes, sir. We can see.
You're not going to college?
No, sir. Not going.
Okay, perfect. So just take let me see if we can just stop. Let just take 3 minutes break, guys. Okay, so after that I will show you, because you should understand the example with this continuation again. There should not be any gap. So there is very interesting example. So I would like to show. Okay, so let me see if I can just pause this. Okay, recording. Okay, yeah. So now we have understood the formula, right? So now let's see an example. Okay, so now if you see, yeah, the same thing yesterday. What before this class, what we have seen. So this is a margin of error. Okay, z into alpha by rho for this x bar plus or minus when you do, you will get the confidence interval. Okay, fine. So now if this example, if you remember, so we'll see. So where sigma is a population standard deviation, okay, and n is the sample size, and z is a number known as critical value. Okay, so this z is also known as a critical value, guys. Okay, so if I just forgot to tell you, so this z is also called as a critical value. So what is this? We will see in detail in future classes. Okay, but just try to understand z is also known as critical value. Why this is critical? Because only based upon that value only everything changes, because everything else is constant. X bar rho n is all constant. Okay, but this will change the whole interval. Okay, so now if you see the z is critical number standard deviation, you would like to go from the mean and normal distribution to capture the population mean, and for 95% confident, okay, roughly we'll go to the 2 standard deviations, etc. Okay, we'll see. For example, if okay, I need to just give a recap of our example. So population ages we have considered. Okay, so the other day in the before few classes, okay, we considered the population ages. If you remember, we took 2 types of distributions, and then we have concatenated both of those, and we got the population ages. Remember, and then we took a sample of 500, and we saw it is almost close to the population ages. Okay, so just recollect this value, this concept. Okay, so now what we are doing over here is, okay, so from this population ages, okay, let me check my pen. Okay, so from the A population ages, so I am taking a sample of 1000. Okay, sample size is 1000. Okay, input out random choice, and that sample mean I am calculating a sample mean. That means what? Just from this population ages, what was the count of population ages, guys? I think it is 2.5 lakh. Do you remember? Yeah, so 1 lakh, 1.5 lakh, 2.5 lakh population. Okay, so from that 2.5 lakh population, what I'm doing, simply I'm taking 1000 sample, random sample. That's why random dot choice. You will get random values, 10,000 random, calculate the mean of that, put it aside, sample mean. Okay, so now what is my goal? My goal is simple. This population, okay, see, I'll just try to connect with this same goal. We have a population whose mean is, I don't know, but I'll take some samples, do everything, and give you an interval. This interval, what is interval? What is interval? We give few intervals. Yeah, this interval with some confidence level, which will capture the true population. Clear? Same thing I'm also doing over here. So I'm saying this is a true population ages, and this will have some true population mean. This will have population mean, which is mu. Okay, sorry. This population, actual true population, will have its mean called as mu. Okay, which I don't know. I want to capture this in some range. Capture it in some range. This range is called confidence interval. Clear? So what I'm doing, I took 1000 samples. After that, Z critical value, right? So Z critical value, the Z value in other sense, I want to calculate. So what did I do? So I'm just trying to calculate the normal distribution probability. So PPF value. Okay. So from the Z table, I'm taking at what value? At 0.975. Why, guys? 0.975? Because at 95% confidence level. Okay, these are the 95% confidence level. See, let's calculate 95% confidence level. What was our value? It is at 0.975. Can you see here? Because this will be 950, sorry, 0.95, and remaining part will be 0.05 by 2, 0.025. So it will be, this point is capturing how much area? 0.950 plus 0.25, total 0.975 area it is capturing. Is that clear?
Yes, yes.
Okay, so that's why I'm giving 0.975 as a quantile. Okay, and that will be critical value. And now also, if you see what is the formula which we have? The formula which we have is this one. So x bar plus or minus margin of error. The actual formula is plus or minus margin of error. Okay, so means what? Same thing. X bar, see, x bar plus or minus, this whole thing is also called as margin of error. Agree? Whole thing is also called as margin of error. But what is the margin of error formula? The same thing. Z into Z at alpha by 2 into rho by square root of n. Clear? This margin of error is Z into rho by square root of n. Are we good till this point?
Okay, I mean Z alpha by 2 into rho by n. That's what.
Yeah, margin of error. The same formula. What we have written over here.
Yes, yes.
Z into alpha by 2, same thing, but only this particular part is also called as margin of error, guys. Okay, I think I already told you in some way in the back. You see, point estimate, our point estimate is x bar plus or minus margin of error. Okay, so now margin of error is Z into alpha rho by square root of n. Okay, the fundamental formula will not change. That is x bar plus or minus Z in Z at alpha by 2 rho square root of n. That will not change. Okay, different ways of calling it. Okay, fine. Now this is my margin of error. So over here, you know the x bar. What is my x bar? X bar is a sample mean. Agree? Margin of error is what? Margin of error is Z. What is Z? Z at Z critical value. Okay. Into rho. What is rho? Population standard deviation. Okay. This is when we know the population standard deviation, guys. This approach I told you, remember? Into square root of n. Okay, so how you can calculate this margin of error? Z critical value, from where you are getting the Z critical value, from 0.975, it will calculate, it will get Z critical value into rho is what? For this population ages. Okay, if you calculate dot std, you will get the population standard deviation. Okay, so that is my rho. Done. And square root of n. How you get the square root? From math library, you will have square root function in that give the sample size. N is 1000. Okay, so once you do that, it will give you the margin of error. Okay, that margin of error, if you do plus or minus to our sample mean. Okay, so that means sample mean minus margin of error and sample mean plus margin of error. Simple. It will give you the confidence interval. Getting? Which line is not clear? Tell me, guys. I will explain that line.
Clear, Santosh. So from this, we will remove both margin of errors. Like only we will have only 95% middle one. That's right, interval.
Yeah, you can say that. Okay, so that means we are capturing this particular area. Okay, so this area alpha by 2, Z alpha by 2. So you want to calculate this points Z alpha by 2, Z alpha minus Z alpha by 2 plus Z alpha by 2. Okay, so you want this area. Okay, so this much is happening between what? That you will get this. Okay, so but if you go by the formula, I would say that is easy. Okay, in the formula x bar plus mean of error, so margin of error. Okay, so for 0.975 at 95% confidence level, how much, what is Z critical value? We are printing Z critical value is 1.95, 959999 something. Okay, so how much we got? If you see in our case, how much we got? 1.96. Clear? Same. 1.9559, 1.96.
Yes, Santosh.
Okay, so this Z alpha by 2 value we got 1.96. Same thing. That value it will put over here. Okay, that value it will put into the equation. It will calculate this value to get the margin of error. Just sample mean, sample plus mean, sample minus mean. You got the interval. See, this is interval. Confidence interval at 95% confidence level. Clear? Now,
Clear, Santosh.
what is the point of this confidence interval? It will capture the true population mu in between this. And what is the true population, guys? If you see over here, the true population is See, what is the actual population mean? 43.00. Agree? And if you see over here, we are having, this is a range 41 from 41. Okay, so from 41 to 43, somewhere 43.3, somewhere this 43.0 will be captured. The true population mu 43.0 will be captured, and that is happening. Is it clear? See, notice that the confidence interval we calculated, that means this interval captures the true population 43.0. Okay, this will be less than this, right? It will be somewhere over here. Everybody clear how we can capture the true population?
Yes, sir.
Okay, but now guys, there is actually, everybody will actually understand till this point, but after what I'm discussing now, that will be a little tricky thing to understand. Okay, so that is actually the main important thing you need to understand. When I'm saying 95% confidence, observe carefully. When I'm saying 95% confidence, you took all this value, you got Z, margin of error, everything you have understood. Okay, simply you have after this class, right? So I'll share this notebook, confidence interval notebook. Okay. Oh no, tomorrow we need to discuss one more scenario. Yeah, I'll share. You can also go through this. Okay. So at 95% confidence, you have considered this value, you got this interval. Okay. So you got this interval. That means what? Some interval you got, which is called as confidence interval. Confidence interval, which will capture the confidence, sorry, true population. I'm saying at 95% confidence level. What does that mean? What does this mean? I just told you before few minutes, but I'm just repeating it again. I am saying somewhere in between this confidence interval, I'll capture this true population, means that this is 95% is not the probability of finding mu. It is not at all the probability of finding mu. It is just, I am confident that this confidence interval, okay, will capture the true population. Okay, in other words, I will tell you very simply, you will understand. See, so what does actually mean is this point you need to always remember, guys. Okay, see, when I'm saying 95% confidence means, okay, when I'm saying 95% confidence means, okay, that means if I conduct a experiment 100 times, okay, if I conduct a experiment 100 times, okay, 100 times, what does this mean, guys? 100 times I'm taking random samples. What is my experiment? Taking random samples, okay, from a population. First time, if you take, let's say, first time, I'm taking 50 samples. Okay, I'm taking 50 samples. Okay, and this will have some mean x1 bar. And second time, I'm again taking 50 samples. Okay, this is one more experiment. Okay, so it will have some x2 bar. Okay, like that, 100 samples, 100 experiments I'm doing. Okay, so 100 the time. Okay, 100 the time, I'm taking 50 samples. Okay, this sample will also have some mean. Okay, so now out of this 100 times, okay, so out of this 100 times, when I say 95% confidence level means the actual statement which it means is when you conduct the experiment 100 times, okay, out of these 100 times, we will be 95% sure. Okay, so we will be 95% of the time. Okay, 95% of the time we will be sure, or in our case, it is 95 times, because 100 times 95% confident is 95 times. Okay, 95 times we are sure that x bar, okay, our x bar, okay, our x bar, our true population mean, okay, our true population, sorry, x bar is what? Our sample mean. Okay, our sample mean will be in the range of given confidence interval. Okay, that means what? You are giving some confidence interval. You are giving some confidence interval. To that interval, you are saying you are, sorry, just give me a second. 161 rupees received in your Paytm has been settled in your bank account. For more information, check your Paytm for business. Okay, Okay, so I'm saying you have conducted experiment, okay, and you are saying you are giving this confidence interval, okay, and you are saying, hey, this confidence interval is for 95% confidence. What does that mean? That means if you conduct this experiment n number of times, let's say 100 times, okay, there are 95% of chances. That means 95% of the times your success that your true population will be captured between this mean, between this confidence interval. That means there are 5% chances that your true population will not be present in this. It is just about speaking about what is your success rate in capturing the true population and what is your failure rate in capturing the true population. That's it. It is not speaking anything about the true population. True population is already there over there. Okay, when you have a population, obviously it will have some true population mu. Whether you know it, whether you can calculate it, whether you can get the access to complete data, that is a different story. Okay, but fundamentally, if you have a population, any data will have some mean. Okay, that is one point. Our goal is how many times we will be able to capture it confidently. So at 95% confidence level, it means that if you conduct an experiment 100 times, 95% of the times or 95 times, you can be sure that your mu, okay, your mu will be captured between this confidence interval. Okay, but 5 times, okay, 5 times there are chances that it will be missed from this confidence interval. Okay, whether that mu is you are able to capture this or not, okay, that is a point. Okay, so 5 times, okay, there is 5% chance of failure that even though you have this confidence interval, okay, fine. So your mu will not be captured in that. That means what, guys? That means what? Are you trying to understand this? Mu is always the same. Your confidence interval, okay, whatever the confidence interval you are getting, that will change, right? So first time if you conduct, okay, first time if you take a set of these values, it will have a confidence interval some CL1. If you again take some random samples, it will have confidence interval CL2. Getting?
Yeah, Santosh.
Yes, sir.
Right. So every time you take the samples, okay, randomly samples, first time you take randomly 50 sort of samples and you calculate all this scenario and you calculate the confidence interval, it will have some range. Okay, now if you take another set of samples, okay, so obviously it x bar will be different. The x bar whatever you're doing x bar, that will be different. So confidence in levels will be always changing, not greatly but slightly. Okay, so but mu is mu. Population we can't touch it. Okay, that is mu. But my goal is roughly with a 95% confidence level. If I'm saying 95 times, I'm confident that whatever the true population there, right, that will be captured between the confidence interval I'm giving. Okay, all this confidence interval what I'm giving, okay, confidence interval what I'm giving, 95% of the chance is there that true population can be found over there. But 5 times, 5% of the time, that means 5 times there is a possibility that it can skip. That means even I get a confidence interval, you cannot find the true population over there. It can skip. Is it clear? So, but never in any interview, if they ask, hey, what is the confidence level? Is it the probability of finding the true population? No, that's not a point, because there is no need to find the true population. Okay, because it's already there. You don't need to calculate that. We are only just trying to give some interval, and that for that interval, I am giving some confidence level such that how many times, if I conduct this experiment 10 times, 20 times, 1000 times, in this 1000 times, what is my success rate? That means out of 1000 times, how many times I can expect that true population will be captured. Because from the same population, you will come, see Karthik will come and he will conduct a set of 20 times. He will take different samples. He will have x1 bar, x2 bar, x3 bar. For all of those, that will be called a sampling distribution. And for all of the sampling distribution, he will have x bar. And with that, he will calculate x bar. He will say, hey, my formula is x bar, x bar plus or minus z into alpha by 2. What's happening to my system? Z into alpha by 2 into rho by square root of n. Okay. Now Meghana will come. She will say, hey, I will also take some set of samples and I will also have my own sampling distribution, x1 bar, x2 bar something, and I will have my own m bar. Okay, if this is xk bar, Karthik's, if this like this. Okay, and now this formula will become x m bar, okay, and plus or minus z into alpha by 2 rho by square root of n. Okay, so this will be xk. Like that, Sirisha's will be x bar s. Okay, so now what is changing? This Z into alpha by 2 will be same because it is the same area, and rho is what? Rho is the population standard deviation or variance, which will be same because population will be population. N is number of samples. Number of samples is obviously same because every time if you take the same samples, all three of people. But this X bar is changing. From where this X bar is changing, guys? Because from the samples you are taking, because your set of samples is different. Karthik's is different. Megha's, mine is different. Everybody's samples are different. So everybody's sampling distribution will be different. So everybody's sampling mean. That means mean of all these samples will be different. Getting? So obviously the confidence interval will be different. This is your confidence interval. This is her confidence interval. Like that, you can have hundreds of confidence interval. Getting? Are you guys able to understand? Yeah. So out of these hundreds and thousands of confidence intervals, now because that is a importance of confidence level. Why we are studying confidence level? Because you can calculate, you can extract as many samples as you want. But when you attach a confidence level, I am saying out of this all, like if 1,000 people are taking 1,000 samples and creating 1,000 intervals, out of this all 1,000 intervals, I need to know what is my success rate. That means if you take 95% confidence, that means out of this 1,000 confidence interval ranges, 95% of them, there is a probability that you can go and search, you will find the mu. Okay, so in this, I don't know, in this there might be mu, in this there might be mu, in this there might not be a mu. Okay, that means why there is 5% of failure chance. Okay, so it is just saying about the success rate or the chances of capturing the true population between the given ranges. That is a fundamental point. Is that clear to everybody? Any doubts in my words? You can be honest, guys. That's fine because all these are new concepts. It's completely fine if you don't understand it first time. I'm there to explain. That's fine. So is this clear?
Yeah, understand, Santosh, but we need to once recap this so we'll get clear. As of now, it's fine.
Okay. Okay, fine. So we'll show an example. So I'm saying, so we'll conduct, okay. So we'll conduct, here we took only one sample, right? So we took only one sample, and with one sample, you got one confidence interval. This is a confidence interval. And we have seen that population is, we are able to capture the population. At least, is this code example clear?
Yes, sir.
Okay. So instead of one sample, I'm saying in this example, what if we take multiple samples? Okay, so we'll see. So now let's create several confidence intervals and plot them to get a better sense of what does it mean to capture the true mean. Okay, so when I'm saying we'll capture the true mean, 95% times we will capture, 5% times it will not capture, what does it actually mean? Okay, so to have that, we need to have multiple confidence intervals. That means you need to take multiple samples. Okay, so my sample size is 1,000. Okay, and now if you see, in the range of 25, that means 25 times I'm repeating this experiment. Each time I am taking 1,000 samples. Okay, each time I'm taking 1,000 samples. Okay, so if you see, yeah, so first time from the population, it is taking sample size is how much? 1,000. Okay, 1,000 samples it is taking, and it is calculating the mean, and it is appending to sample means. Okay, so I have created a sample means. Okay, see here, let's go step by step. Okay, we have a sample means. First time it is coming in the range of 25. That means 25 times it will do this experiment. First time it will come here from the population. Take sample size is how much? 1,000. Okay, take 1,000 samples from this 2.5 lakh population ages and randomly take that, and that is sample. Now next, sample dot mean, you will calculate, that is sample mean. And to the sample means variable, just append this sample mean. Okay, so again come over here, take second set of time, you again take next set of 1,000 values, calculate its mean and append this like this. Now this will have 25 values, 25 means. Okay, 25 means. So after that, okay, so yeah, but for each and every sample, what we are doing the whole scenario. Okay, so what we are doing, try to understand. So for first set of value, once you got the sample mean, what we are doing again, the z value is 0.95 and the population value is this. Okay, and we are having a confidence margin of error, confidence interval, Okay, same thing, whatever you are doing, exactly the same thing you are doing here. Also, you are taking first time, you're taking 1,000 samples, and for that 1,000 samples, you are calculating calculating the Z critical value and the margin of error, everything, and you got confidence interval. Okay, this same experiment, just I am repeating 25 times. That's it, nothing. So it will have 25 means. All this 25 means I am capturing it sample means, and it will have 25 set of confidence intervals. Agree? Just like how the above part is having only one set of confidence interval. Okay, like this, it will have 20 confidence intervals. I'm appending to intervals. Okay, so this intervals I'm appending confidence interval. Okay, 25 set of confidence interval it will have. Okay, for each set of sample. Is this clear till this points?
Yeah, Santosh.
Okay, so simple. So instead of repeating it once, same sample size 1,000. So I am doing it for 25, range of 25. Cool. So now we have all the, for each sample, that means 25 samples, you have the sample means calculated. Okay, and you also have the intervals also for that corresponding confidence interval for each of the sample. Now, if you plot here, this plotting is interesting if you see. So if you plot here, so what I'm plotting on the horizontal line. Okay, see, this horizontal line is one, but before that, what we are plotting the vertical line. Okay, so here from range of see, np dot range of 0.1 to 25 at the range of 1. Okay, so that means what, 25 experiments we did. For each experiment we got a sample set, and each of that will have one mean. Okay, so 25 means we'll have. So to plot that, I am saying what, start from 0.1, go till 25, increase one each. That means, in other words, it will take 1, 2, 3, 4 till 25 you will get. Okay, so 0, 1, 2, 3, 4, 5 like that. From 25 you will get. Okay, so 25 values we have created. Okay, and y is sample means. Okay, y is sample mean. Okay, so in on y you are plotting all the sample means. Okay, and what does this sample means look like? So do I have this? This is not defined. Actually, let me run this. We'll see what we are going to get. Okay, so first of all, we need to have the population ages, right? Okay, so we have the population ages. Okay, so that if I run this, okay, so we got this. Okay, now see, these are all okay, this is the sample. So if I see the sample means, see, for each time, so first time when you take the, so here in this scenario, so in this scenario, what is the sample mean? Let me also print the sample mean. See, sample mean is 42.523. In first scenario, when you take only one sample mean is 42.523, and Z critical value is this, confidence level is this. Now here I'm repeating 25 times. Okay, and each time the sample mean what you are getting, like this 43, you are adding to the sample means list. Okay, so see, these are the 25 sample means. Clear? Can you see it clearly? And you're also having, for each of this sample set, you also have the confidence interval which you're appending to this list called as interval. Okay, so if I open this interval, see, just like how you had one single interval for one single sample, now you'll have 25 such intervals. Clear? Clear is this code?
Yeah.
Okay, perfect. So now these samples and intervals, what we are doing? So on y-axis, I am plotting. See, on x-axis, I just want from 1 to 25 because 25 experiments I have done. On y-axis, I am plotting y sample means. Okay, what does sample means? So these are my sample means. Okay, so these are my sample means, the complete sample means. Okay, so after that, see, after that, what I'm doing? What is the mean of the given value? So top and bot in the interval. Okay, so what is this interval? Interval is these values. Okay, for each of this interval. Okay, so if you take one particular value, for example, here I will take the last one. See, this is for top and bot in interval. Okay, that means what, this is top, this is bot. Okay, for A and B, for example, A and B, I'm doing a minus b by 2. That means I'm taking the middle value of this interval. Okay, I am doing a middle value of this interval. Okay, so interval is what? Interval is the given confidence interval. Okay, guys, the given confidence interval is the interval. Okay, and I am just trying to put a dot at the middle point of that. Okay, I'm trying to put a dot at the middle point of that. Oh, that's why I'm doing this minus this by 2. You'll get a value there. I'm just representing as 0. Okay, a dot. So that's why these lines, whatever you are seeing over here, okay, whatever you are seeing over here, so those are the lines which got created. Okay, and the middle point is its mean. This is one confidence interval, guys. Okay, so every line here is a confidence interval. For example, if you see 42 to 44, okay, see, this will start at some 42 till 44, and there is a dot at the middle point. Okay, you are also indicating the middle points or mean of those confidence interval. Is this clear?
Yes.
Yes.
Okay, fine. So we have just plotted the confidence interval. Okay, that's it. So we at y-axis we have took mean, at x-axis we have took the number of samples we have considered, and we have just plotted the each confidence interval. So all these values. Okay, see, first one is 42 to 44. Next is 42 to 43. Okay, see, 42 to 43, a little lesser than that. Okay, next one is a bit more, 42 to 44. Okay, 42 to 44. Okay, somewhere like that. Okay, so each of these we have plotted, and a middle point we have just indicated. So now this is fine. These are confidence intervals. Now, what is the fundamental goal for all these confidence intervals? Whatever the confidence interval, my point is only one single point agenda. I want to capture true population mean. That's it. No more good than this. True population is what? Population ages. What is the mean of it? The actual true population ages mean is what, guys? How much it is? 43.00. Okay, so this value I want to know whether I'm able to capture. If in one single example I'm able to capture, that's fine. But in all these 25 examples, if I'm able to capture or not, I want to see. Okay, so sometimes I might capture, some I not capture, I may not be able to capture. We'll see. Okay, what was that? 43.0023. This value, right? So I am just drawing. First, we have got this initially when I for this value you will have only the lines. Okay, so after that what I'm doing, see, I'm plotting a H line, horizontal line with red color. Okay, some width of this. Okay, so from x from 0 to 25, that means start from 0 to 25. Okay, see here, x is from 0 to 25, start from there, but y will be at 43.0023. Okay, wherever the y you are having 43, because this is my population mean, actual mu. Who is the hero in our case? This guy is standing over here. Okay, so if you just draw a line, okay, if you just draw a line, fine. So all these are what, guys? All these are what? These lines are. Can you tell me what are these lines? Each line is a
one interval.
One interval. Perfect. So I'm just I'm just plotted those in space. I'm just drawing a line, and we'll see whether it is cutting that line. If it is cutting, that means we are capturing. Understanding? It's just a pictorial representation. You are drawing a line and you are just cutting it with that line, with our population mean. If it is touching somewhere, that means it is able to capture that population mean. Did you get that? This is its top value 44. Okay, 44. This is my 42. And if you are drawing some 43 value, and if it is cutting this, obviously it means it is capturing that. If it is coming over here, or if it is coming over here, that means it is not capturing.
Means it's not present in that.
Or it is correct, because this range is between 42 and 44 only. If it is cuts, then it is capturing that. Somewhere over here you will have the true population. Clear? So same example, if you observe here, almost all the lines we are able to capture, but this guy, if you observe, he is moving away. He is not interacting with this line. Observe this guy.
Yeah, Santosh.
Okay, so that means what? Why this is happening? Why this is happening? Because ours is not a 100% confidence level. Ours is only 95% confidence level. That means there is a chance of 5% error. Okay, 5% error is possible. Okay, getting? So if you see the last third one, 1, 2, 3, this last third one is this guy. See, this guy is starting from 43.4 and going till 45. But my true population is 43.00, less than this only. Agree? So that's why this guy is starting from here. So that means what? You took 25 samples, but in the 25 samples, some sample randomly, whatever the values you are taking, okay? So it took samples in such a way that its confidence interval got created like this. And that is missing the true population. Okay? But most of the samples what you take are able to conveniently capture the true population, and some of them are actually capturing it very well. For example, if you see this one, this particular line, it is almost at the middle part. It is perfectly capturing it. Okay, some are capturing this particular line. It is almost capturing with a little tension, I would say. Okay, but this is conveniently capturing in the middle part. Agree? But one guy is missing. Why that is happening? Because we calculated this confidence interval. All this confidence interval what you are getting are at a 95% confidence level. Okay. So if you change this to 100 or if you decrease this to 70, what will change? Obviously, this value will change. Agree? This value will change based upon that confidence interval will change, and also the plotting will also change. And you can experiment. It will be a nice experiment to see if you are increasing the confidence level, whether the chances of capturing are increasing or not. Again, if you're decreasing the confidence levels, whether the new intervals which are getting created, whether they're able to capture the true population with a more success rate or not. Okay, but is this experiment clear? Okay, I think it is very beautiful example. So where it is showing that if you take 1,000 samples, what does that mean, guys? So I have clearly told you over here. Yeah, so if you conduct an experiment some n number of times, 95% of the times there are chances to capture our true population in the given confidence intervals. Okay, for each and everything you will have, see here this example. So everybody will get one confidence interval. So you will have 95% of the time you will be success to capture the true population. Sometimes you will miss. That's fine. Same thing is happening over here. You conducted it 25 times. Each time 1,000 samples. So you will have 25 intervals. 25 sample means 25 sample means intervals. So and your goal is to capture the true population, but sometimes you can miss. That's fine. So here also you will see. Notice that in the above plot, all but one. Okay, only one, which this one of the 95% confidence intervals overlap the red line marking. This is to be expected since a 95% confidence interval captures the true population 95 times. That means you would expect our interval to miss the true mean 5% of the time. Clear? Is this line?
Yeah, Santosh.
Okay.
But yeah, I have doubt. I mean,
yeah.
So is this 95% is it's standard?
Actually, it is standard. That's a good question. So you can calculate for any number of intervals because it's just simple calculation, but usually people will go for 95% confident.
Okay. And it's always, I mean, we have taken area standard, I mean, normal deviation, like we are like eliminating like erroring part is like starting and ending part. So may it vary from scenario to scenario?
No,
Sometimes.
this will not vary because this is regarding the standard normal distribution. We want the value at z alpha by 2. What will vary? Only, see, this concept is same, but based upon your confidence level. So if you say I want only 50% confident, okay, what will become? This will become 0.50.
Yes.
And the remaining part will be 0.50, and each side will go 0.25.
Yes.
And this part, so this particular point is capturing how much area? This whole area.
0.75.
Correct. Okay, that will be 0.75. Now you will go into this table and open this and see it is 0.75. Yeah, 0.75. Okay.
Yes.
That means 0.6 plus 0.08. Some 0.68. So
Yes.
0.68 will be the value for you to replace over here. This will become x bar plus 0.68.
Okay.
Okay.
Yeah.
Yeah, but area is same because this is the point which will capture this whole area.
Okay. So
Okay.
95% is standard basically. Yeah.
Yes, 95% standard. Yeah, usually they say 95% confidence. Okay, but you can change. Sometimes it will be 90, 95% will say. That we will see. In next concept is, I'll tell you. Next concept is we'll have something called hypothesis testing. So there we will see.
Sure.
Okay. So yeah, guys. For you, any doubts, Meghana?
No, sir.
It's clear, right? Okay, so that's fine, guys. Okay, so now if I just go back, we did all this when, so initially when I told you this scenario, I told you there will be two cases. One is when the population variance is known. What is our population variance? This row, whatever you're seeing here, right? That is your population variance or standard deviation, anything. Okay, that is known. Only when you know this, you will do this formula x bar plus z alphabet, everything. But there will be a scenario where if you don't know, okay, so that we will be seeing in tomorrow's class. So where if you don't know the standard deviation of the population, you would go for some other distribution that's called T distribution. Okay, it's also called student distribution. Okay, that we will see in the next class. Okay, so with that we will be concluding the concept of this confidence interval concept. Okay, so this confidence interval. Okay, so this confidence interval part, so as I said, there will be two scenarios when population variance is known, not known. So known is, I've shown you clearly regarding the formula, regarding the example also. Okay, everything. So tomorrow we will see. Okay, tomorrow you guys will join, right? Saturday.
Yes, Santosh. Okay.
Okay, so tomorrow, if tomorrow you join, so we will complete the scenario where you don't know the population when this is not known. Okay, as I said, we will use some T distribution. It's also called a student distribution. Okay, it's called student distribution. Okay, so with that, this will be completed, and after that, we will have a new topic. The final concept over here is called hypothesis testing. Okay, which is a very important concept in the statistics part. Okay, which very important from the interview perspective. Okay, so without this question they will not leave you. Okay, that's for sure. So that will be the final topic or section from the stats module, so where you will have a bunch of new concepts, I would say. Okay, so with that, I'm aiming to wrap the stats in, as I said, this week. Okay, 30th, or if it takes just 1 or 2, okay, just 2 days from December I will borrow. So with that we will complete the stats module. Okay, post that we will be on fast track, guys, because I'm going a bit slow in stats because lot of new things. Obviously every new concept we studied is mostly new concepts. Okay, so that's right. So once that is done, we will switch to fast track mode, so where we will, as I said, NumPy, pandas, matplotlib, machine learning, everything, most interesting stuff will be starting, and that will be more practical, and that will be also more interesting, guys. This is important, but it's not that interesting, I would say. Okay, it requires more attention, and it's not too practical. Okay, mostly we will be discussing about the theory part, right? Okay, sometimes it might be a bit boring. Okay, but I hope you understand the concepts. Okay, so don't neglect stats. I would say that's a fundamental thing. Never neglect stats in data science. Okay, so but once this is done, right, so next module will be completely practical, very interesting. NumPy will see a lot of examples, everything such that. Okay, so that would be from my end. Okay, so tomorrow we will join and we'll wrap this up. Okay, so yeah, any doubts, guys? Any questions? Are we good?
Clear, Santosh. Tell me.
Okay, fine. Cool, guys. Let's meet tomorrow. Thank you so much. Thank you so much for joining.